Welcome to the Explainer. You know, every single time you send an email, stream a video, or just browse a website, there's this incredible hidden process making it all happen. Today, we're going to peel back the 7 layers of that secret blueprint, the OSI model. Alright, so here's our game plan. First, we'll look at the why, the big communication headache that started it all. Then we're going to climb this ladder of layers, from the physical wires all the way up. We'll see how your data actually travels and how its safe delivery is guaranteed. And finally, we'll tackle the big question. How does this old model stack up against the real world today?
So let's dive right in. Why do we even need a model like OSI? Well, to get that, you really have to appreciate the mind-boggling complexity that our networks deal with literally every single second.
I mean, just think about it for a second. How does this simple email get from your laptop across the globe and to a server in just seconds? You've got totally different devices, different networks. Maybe your Apple laptop is talking to a Google server running Linux, going through who knows how many different routers along the way. How on earth do all these completely different pieces of tech, made by tons of different companies, speak the same language?
And that was the big problem. In the early days, networks were like these little isolated islands. Each one had its own special, proprietary language. They couldn't talk to each other. So to build bridges between these islands, engineers needed a universal standard, a common framework, kind of like a Rosetta Stone, but for computers, something to tame the chaos and make global communication even possible.
And the solution they came up with was, well, it was brilliant. Instead of trying to create one giant, super complex protocol to solve everything at once, the idea was to break the problem down. Let's chop this huge task of network communication into 7 smaller, much more manageable layers. This whole concept is called a protocol hierarchy. And here's the magic. Each layer has one specific job to do. It provides a service to the layer just above it, and it completely hides all the messy details of how it gets that job done. And that is so powerful because it means someone can invent brand new Wi-Fi technology down at layer 1 without having to know a single thing about how, say, Netflix streams a movie way up at layer 7. They just trust the other layers to do their part.
And this is a really key idea to grasp. Each layer on your machine is basically having a conversation with the same layer on the other machine. So layer 4 on your computer is only talking to layer 4 on the server. It has no idea, and frankly it doesn't care, if the connection below is Wi-Fi or a cable plugged into the wall. It just trusts the layers below it to handle all that. This peer-to-peer communication at every level is what makes the whole thing hang together.
Okay, to make this all feel a bit more real, let's use an analogy that I think you'll find super helpful. Imagine you're mailing a physical package to a friend. We're going to follow that package every step of the way as it gets prepped for its journey, starting at the top and working our way down through these layers.
All right, let's jump down to the bottom of our ladder. These first 3 layers are all about the physical journey of your data. This is the real nuts and bolts stuff, how we actually get those bits and bytes from point A to point B.
So layer 1 is the physical layer, and it's exactly what it sounds like. It's the actual physical stuff. The wires, the fiber optic cables, the radio waves for your Wi-Fi. In our package analogy, this is the fleet of trucks and the network of roads. This layer has no clue what it's carrying. Its only job is to move raw bits, just a stream of ones and zeros from one place to another.
And as you can see, those roads can be pretty different. Your data could be traveling as electrical pulses through an old-school copper cable, or it could be zipping along as literal pulses of light inside a fiber optic cable. And that fiber optic cable, that's like a superhighway for data, letting us hit incredible speeds over huge distances.
Okay, moving up to layer 2, the data link layer. This layer takes that raw stream of bits from layer 1 and starts to give it some structure. It bundles them into packets called frames. Now, in our analogy, this is like taking your letter and putting it into a standard-sized shipping box. Then you write the local address on it, the specific house number and street. In the computer world, that's the MAC address, a unique ID for your device that tells the local network exactly which computer on the block this package is for.
All right, now let's zoom out a bit to layer 3, the network layer. This layer is the master navigator for the entire journey. It adds the global address, which you probably know as the IP address. So if the MAC address was just the house number, the IP address is the whole thing: street, city, state, and zip code. The network layer's one big job is to figure out the best possible path for that package to take across the entire internet. And the real workhorses of layer 3? They're routers. You can think of them just like the big, bustling postal sorting facilities of the internet. They look at the IP address on every single packet, and in a fraction of a second, make a decision. Okay, what's the very next hop that will get this packet closer to where it needs to go? And then they send it on its way. Okay, we've handled the physical journey. Now let's climb up to the top 4 layers. If those bottom layers were the postal service, the trucks, roads, and sorting centers, then these top layers are more like the administrative office. They're all about making sure the contents of the package are correct, secure, and actually understandable when they arrive.
Next up is layer 4, the transport layer. And this one is all about quality control. It takes the big chunk of data from the layers above it, and if it's too big, it chops it up into smaller pieces. Then, its crucial job is to make sure every single one of those pieces arrives at the other end, in the right order, with no errors. It's basically the certified mail with tracking number service for your data.
Then we have layer 5, the session layer. You can think of this as the conversation manager. It's the one that opens the communication line between 2 applications, keeps that conversation going, and then closes it down neatly when it's all over. It's also super useful for things like big file downloads. It can add checkpoints along the way, so if your connection drops halfway through, you can just pick up where you left off instead of having to start the whole thing from scratch. Pretty handy, right?
Moving on up to layer 6, the presentation layer. This is basically the universal translator of the network. It deals with data formatting, making sure that the data sent from your computer is in a language that the receiving computer can actually understand. This is also where things like encryption and decryption happen. So in our analogy, this is like writing your letter in a secret code that only your friend has the key to decipher. And here we are, at the very top of the ladder, layer 7, the application layer. This is the part you and I actually see and interact with every day. It's your web browser, your email program, your favorite online game. Going back to our analogy one last time, this is the actual letter you wrote in the first place. It's the whole point of this entire journey, the content that the whole system was built to deliver. So there you have it. We've climbed all 7 layers of this really elegant and beautifully organized model, but there's a crucial question we have to ask. Is this really how the internet works in the real world? And the answer might surprise you. This is maybe the most important thing to take away from all this. The OSI model isn't the law. It's more like the textbook. It's a conceptual model, a blueprint that gives everyone, developers, engineers, network admins, a common language and a framework for thinking about, designing, and importantly, troubleshooting networks. The reality is, the internet we use every day doesn't actually run on the strict 7-layer OSI model. It runs on a leaner, more practical 4-layer model called TCP/IP. But, and this is a big but, even though the OSI model as a whole was never really implemented, the ideas behind it, the whole concept of layering, are absolutely vital. You can't really understand how networks work without it. This chart here does a fantastic job of summarizing everything. You can see each layer, its main purpose, and some of the real-world tech that operates there. So down at the bottom, layer 1, you've got your physical cables. Jump up to layer 3, the network layer, and that's where you find routers and the IP protocol. Layer 4, transport, is home to protocols like TCP, which handles that reliable delivery we talked about. And all the way at the top, layer 7, you've got the apps we all use running on protocols like HTTP for the web. So the big takeaway is this. Even though the internet might not follow the OSI model to the letter, understanding this layered structure is absolutely crucial. The next time your Wi-Fi goes out, you can think like a network engineer. Is it a layer 1 problem? Is the cable unplugged? Or is it a layer 3 problem with your IP address? The answers to everything, from just fixing your home internet to building the future of our connected world, really do lie somewhere within these 7 powerful layers.